Hey guys, and welcome back. Today we're going to have a look at compound interest. Now, if you're new to this channel, welcome. My name is Miss Danielson, and I'll be taking you through a lesson today, followed by a pause and practice exercise, and as always, the answers are taken up at the end. If you weren't with us for our lesson on simple interest, I highly recommend that you start there, and I'll be linking it down in the description box below. Now, let's get started. Now, simple interest versus compound interest. Please, 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 no matter how good or bad you think you are at math, don't think, compound interest sounds a bit confusing. I'm just going to stick with simple interest. They are not the same thing. You're going to want to learn about compound interest. Here's a graph to explain to you why. Here you see this blue line shows simple interest. You see is a straight line. It's a linear relationship. That is, as time goes along, your simple interest is increasing, but always at the same rate. Whereas compound interest, which is our red line, which isn't a line at all, it's a curve, shows that as time progresses, your interest starts growing at a faster and faster rate, at an exponential rate. Whether you're able to do it right now or not, it is definitely something worth learning about. So let's get started with that. First, with simple interest and compound interest, we need to define our variables, and they are the same variables. I stands for interest. That's the amount that you're earning on top of your original investment, or the amount that you need to pay back on top of the original loan. So we can consider this the profit on an investment or the extra cost to pay back a loan that you might have taken out. P is the principal amount. That's a starting amount. That's the amount that you initially borrowed or invested. T is the amount of time that you're either investing your money for or borrowing your money for. This time could be measured in a number of years or months, or it could be every 3 months or every 4 months. So I refer to time as a number of terms, depending on the number of terms you agreed with. R represents the rate of interest. That will always be some percentage amount. It's the percent that you either agree to pay back on your loan or the percent that you were promised as a return on your investment. So now let's have a look at simple interest. And as I said before, we have seen this in a previous lesson. If this is all new to you, go check out that lesson before. If not, let's get going. Simple interest is a percentage of the principal value for every term. That means that the total amount is increasing linearly, always by the same amount each term. Here in blue, I've shown you the amount of interest earned each term. And as you can see, the blue line is a horizontal line. That means that it's always at the same value. And the red line shows the total interest, which is increasing, but increasing at a constant rate. Here's our formula for simple interest. I equals PTR over 100. Now this is the standard format of the formula, and we did discuss this formula in a previous lesson, but let's just very quickly go through it again. This shows that in year 1, the interest I earn will be R%, remember R is our rate, of our principal amount. In year 2, the interest I will have earned will be the R% of the principal amount I had from year 1 plus a same R% of the same principal amount for the second year. So we're just increasing by the same value as we did in the first year. In year 3, as you can see, this is getting quite long, but it's very simple to simplify this because we're always adding on the same value. So for T years, that is for any amount of time, I would be equal to T times R% of the principal amount, which is where our formula comes from. I is equal to T times R% would be R over 100 multiplied by the principal amount. And that simplifies multiplying a fraction by P and T. I would just have P times T times R as the numerator and 100 as the denominator. So I equals PTR over 100. Let's have a look now at compound interest. And it is a bit more complex, but as we've already seen, it is definitely worth learning. So compound interest, it's a set percentage of a growing total value every term. So since the value that we're finding a percentage of continues to grow, so does the interest that we earn each term. The total value of the investment or loan grows exponentially. And I'll show you what the formula looks like for something that's growing exponentially. But as we've seen on the graph, it's growing more and more each term. So it's not growing at a constant rate, it's growing at an accelerated rate. Let's have a look at the first few years of this kind of interest. For year 1, the interest will be equal to the rate, percentage of the principal value. That's the same as simple interest. But for year 2, we're not just going to find the rate percent of the principal value. We're going to find that rate percent of the total value we will have after year 1. See, after year 1, we will have an interest amount of R% of P, but we will also have the principal value. So we add that to the principal value, and now we find R% of that value. For year 3, you'll see it quickly gets quite confusing, but don't worry, we will simplify this. This is just to understand where the formula comes from. For year 3, I is equal to R% of the total that we would have had after year 2. So as you can see, the interest we earn in year 3 is the same percentage, but of a bigger value than in year 2. And the interest we earned in year 2, again, is R%, but of a growing value, more than what we started with in year 1. So to simplify this, we should consider that the total value of the investment or loan is increasing by R% every term. Now, to increase by a percentage, I do have some lessons about that as well, but we need to keep this in mind. To increase by a percentage is to find 100% of that original value, that is to keep the full value, but also work out an additional R% of that original value. That's what it means to increase a value by R%. So that means that we need to work out 100 plus R% of the value being increased. Remember that 100% is the whole thing. So if I want that value to increase, it needs to be more than 100% of that value. So as a quick example here, if I want to increase a value by 50%, I could just add 50% to the original value, but as you saw, that looked a bit confusing. Much simpler is I can find 150% of that original value. So we're going to put that in action here with our formula to try and get a formula that's a lot shorter, easier to write, easier to substitute into, and easier to remember. Compound interest shows that the total value of our investment or loan is growing exponentially. In year 1, this is the total that we will have after year 1. That is the interest plus the amount that we started with. That's 100% of what we started with plus the R% of what we started with. So that's 100 plus R% of P. After year 2, the total amount we will have will be 100 plus R% of what we had in year 1, which is 100 plus R% of P. In year 3, again, we're going to find 100 plus R% of what we had in year 2. Every year we're increasing by R%, so every year we're finding 100 plus R% of what we previously had. Now you should notice that this is exponential growth because we're constantly going to be repeatedly multiplying by the same amount. We are repeatedly multiplying by the 100 plus R%. Let's show how that looks by continuing to simplify our formula a bit. So in year 1, 100 and R%, I could write that as a fraction. That's 100 plus R over 100, because a percentage is a fraction over 100. And to find a fraction of an amount, we multiply by that amount. So for year 1, 100 plus R over 100 times P. For year 2, remember we want to increase this amount by R%. That's finding 100 and R% of this amount. So we're going to multiply year 1's total value by 100 plus R over 100. In year 3, we're going to do the same thing. We want to increase the year 2's total value by 100 and R%. So in year 3, we're going to do 100 plus R over 100 multiplied by the total value we had in year 2. Still, this may look a little bit confusing for you, so let's simplify this a little bit more. Notice that we're repeatedly multiplying by this blue bracket that we've got. So if you repeatedly multiply by the same value, we can use an exponent to show that. We're basically doing P times this bracket 100 plus R over 100, repeatedly multiplying by that value T times. That means we need to put an exponent of T. So that's our formula. For compound interest, the total amount you will have after T years or T terms is P times 100 plus R over 100 to the power of T. Now I know that looks confusing right now, but once we start using it, you'll start to realize it's actually quite simple. In fact, I guarantee you there's somebody watching this video right now saying, why is she taking so long to explain it? It's easy. It will be easy for you all one day. Now let's just go over a few simple examples. Well, compound examples. You'll see that this formula really isn't as complicated as it looks once you get used to it. Feel free to hit pause at any time to try these for yourself, but you might want to see me go through the first one. So in each of these cases, we're working out the total value of these investments at maturity. That's after the time has passed. In our first example, we're investing a principal of 4,200 euros for 5 years at a rate of 2%, compounded yearly. So using the word compounded, you know it's compound interest. So we're going to use the formula that we got here. We are increasing the principal amount by 2% repeatedly for 5 years. That means we're going to find 102% of the principal amount, and we're going to repeatedly find 102% of that amount 5 times. So the easiest way to input this into the formula is to say, I'm going to take my principal amount, 4,200, and multiply that by 102 over 100. That's 102%. And I'm doing that to the power of 5 because I'm repeating this process 5 times, once every year, compounding yearly. Just to simplify that fraction, I'll bet a lot of you will be able to jump directly to this format of the formula. 4,200 multiplied by 1.02. You see that was 102%? A percentage as a decimal, we divide it by 100, and then we just do that decimal value to the power of the number of terms. So put that into your calculator, and we got a total value at maturity, which is 4,637 and 14 cents. Now this is rounded to 2 decimal places as we always do with money. This is the total at maturity. That's not the amount of interest we earned. Looking at the total amount at maturity compared with what we started with, we have earned 437 euros and 14 cents interest. Okay, on to the next one. Now we've got a principal amount of £3,500, a time of 7 years, and a yearly rate of 1.5% compounded, so compound interest, yearly. So we are going to find an increase of 1.5% of the principal amount repeatedly 7 times. Remember, to increase by a percentage, we find 100 plus that percentage. So we're going to do 101.5% of 3,500. And to find that percentage repeatedly for 7 years, that's to the power of 7. Again, this fraction can be simplified really nicely to turn it into a decimal. That's just 1.015. So 3,500 times 1.015 to the power of 7, that gives us our total at maturity is 3,884 pounds and 46 pence. Again, this is the total at maturity, not the amount of interest we earned. Look at how much we started with. We have earned 384 pounds and 46 pence in interest. Next question, again the same thing, and I'm going to skip out that first step with that fraction. I want to increase $12,450 by 3.2% compounded yearly for 8 years. So increasing by 3.2% is finding 103.2% of the principal value I'm repeating that multiplication 8 times. So I'll do 12,450 multiplied by 1.032 to the power of 8. 1.032 is the same thing as 103.2%. I've just taken 103.2 and divided it by 100 to make it a decimal. Now I just plug that in my calculator, quick and easy, and we get our answer. After 8 years, the total value of my investment will be $16,017.95. Again, that's not the interest. How much interest is that? If you want to find how much interest was earned, look at how much we started with, and we do the total at maturity minus the principal amount, and that gives us our interest. Next question is a little bit trickier because this time we are only investing for 6 months, and this is compounded monthly. So not compounded yearly. This is not putting this in for half a year. This is compounded monthly. But the monthly rate is not 1.8. That is the yearly rate. The monthly rate would be the yearly rate divided by 12, right? Because there are 12 months in a year. So this means that we earn 0.15% monthly, and that gets compounded monthly. So once we've earned that 0.15% interest, we put that back into our total amount, and the following month we earn another 0.15%. Right? We are increasing by 0.15% every month, so we are finding 100.15% per month. So substituting that into our formula, going directly to the decimal version, I've got my principal amount, 5,420, multiplied by 100.15%, which as a decimal is 1.0015. I'm doing that repeatedly for 6 months, so to the power of 6. Plug that into your calculator and you've got it right away. Our final amount after 6 months will be £5,468.96. Finally, we are investing our money for 18 months this time. We're told that the yearly rate is 1.2%, but this is compounded monthly, which goes along well with our time. We need to work out what our monthly rate will be. If we earn a 1.2% yearly rate, monthly, that would be divided by 12. That is a 0.1% monthly rate. So working that through, I want to increase my principal amount by 0.1%. That means I'm going to work out 100.1% of 6,325, and I'm going to do this repeatedly for 18 months. That's 6,325 times 1.001. That's the same as 100.1% as a decimal to the power of 18. Again, plug that into your calculator and you'll get 6,439.82. So 6,439 euros and 82 cents. Now these are relatively straightforward examples because I'm telling you clearly what the principal, the time, and the rate are, and we're just getting used to using the compound interest formula. I hope you found this lesson and practice interesting. Haha, interesting. If I've left anything a bit unclear, please leave me a comment down below so I can clarify that for you. And if you want to stick around, I'll show you some more advanced compound and simple interest questions coming up next.